Hello everyone and welcome to Blockchain Technologies. This is our first session and today we are laying the foundation for everything that follows. What blockchain actually is, how it works under the hood, its core characteristics, how it has evolved over time, and the two ideas that make it tamper-proof, hashing and chaining of the blocks. Let's get started. Here is our roadmap for this session. 5 building blocks. First one, what a blockchain actually is and the problem it solves. Second, how a blockchain works step by step. Third, its key characteristics. In that, the properties that make it different from a normal database. Fourth, how the blockchain has evolved from Bitcoin to smart contracts to enterprise use. And fifth, chaining and hashing, the cryptographic glue that holds it all together. By the end of this video, you will be able to explain all five to someone with zero background. So now let's see what is a blockchain. In simple terms, a blockchain is a distributed digital ledger. That means it records transactions, but instead of living on one's company server, it is copied across many computers. It is called nodes. At the same time, a few things follow from that. Data is stored in linked blocks rather than one central file. Every node holds its own copy of the ledger. New entries need the network to agree. That is called consensus before they are accepted. And once something is added, it's extremely hard to change or delete. Let's see the point of the analogy block. Think of it like a shared Google document. Everyone will access sees the same content in real time and every edit is logged and visible to everyone. Nobody can quietly go back and rewrite the history. To really appreciate what that matters, let's compare it to how things normally work. On the left, traditional centralized systems, a bank, a land registry, a government office, hold the single master record. Everyone has to trust that one authority, and because it's one authority, it's also a single point of failure. If it is hacked, corrupted, or shut down, the record is at risk. Plus, going through a middleman is often slower and costs money. On the right, blockchain flips that. Thousands of nodes hold identical copies of the ledger. No single party needs to be trusted. The network verifies itself. There is no single point of failure. So it's extremely resilient to tampering. And the transactions can settle directly peer to peer with fewer intermediaries. Now let's walk through what actually happens when someone makes a transaction on a blockchain. From the moment it's requested to the moment it becomes a permanent record. Step 1. A user initiates a transaction, say sending cryptocurrency or logging a record. Step 2. The transaction is broadcast to a peer-to-peer network of the nodes. Step 3. Nodes validate it, checking it against known rules. We will cover consensus mechanism in a later session. Step 4. Verified transactions are bundled together into a new block. Step 5. The block is hashed given a unique digital fingerprint and it also stores the hash of the block before it. And step 6, the new block is appended to the chain permanently and transparently for everyone to see. That's the whole life cycle in 6 steps. Keep this flow in mind. Every topic for the rest of the session zooms into one part of it. Let's zoom into step 4 and 5. What's actually inside a block? Let's see it. Every block on almost any blockchain platform carries the same core fields: index, timestamp, transaction data, previous hash, nonce, and block hash. Let's see it. First, index. It's a position in the chain, a timestamp, exactly when it was created. The transaction data, a actual records or transactions stored. A previous hash, the fingerprint of the block right before it. A nonce, a number that gets changed repeatedly during mining. Then block hash. It's a unique fingerprint, its own unique fingerprint. Now, two of these fields are the ones that matter most for today, the previous hash and the block hash. Because every block stores the hash of the one before it. The blocks from an unbroken tamper evident sequence. That's exactly what we are going to explore in detail later in this video. Quick note on the nonce. Miners repeatedly change this number and rehash the block until the result meets the network's difficulty target. That process is called mining, and we will dig into it properly in our next session. It's also worth knowing this nonce-based approach is specific to proof of work systems like Bitcoin. Other consensus mechanisms like proof of stake don't use a nonce at all.